Okay, so a snapshot is what we have seen. Okay, so this is one of the topic of certification basically. Okay, so they will ask you to first have one directory to be snapshotable, and then they will ask you to create the snapshot and save it with some name. Okay, so it's very easy. I mean, to clear the Hortonworks HDP certification is very easy. Now, next thing we are seeing distcp. Okay, distcp is basically a command that you can use to copy the data from one directory to other one. Okay, it will also create the directory if you want. So the directory that we are having here is hadoop-fs minus this wow directory. Let's create this same directory on the other side in Cloudera. Okay, so if I do su, okay, it requires password, so let me set it. hdfs switch user hdfs. Okay, so currently we do not have /wow directory over here. What I want is that this directory with all its data, with all its timestamp, everything should appear somewhere here. Now we need to first see if we can somehow ping this IP address. They're all in the different region, but I think all these machines are in the same virtual network. Okay, so let me first check if the connectivity is proper. So let me ping this from here. So yes, it is getting pinged. So somehow it is available now. Either we can give the host name where our 5070 is running. Okay, so let me try this. Hadoop distcp. Okay, first copy this and try to see that how many options you will get. It's very important command, and basically it will provide you you can scriptize it and do a lot of things just for copying the data from source to destination. So these are all our options that you need to take. So either delete from target files missing in source. So when you try to copy, it will check both the destination and source. It can also see the difference, and you can just append whatever is remaining over there from on the target side. Okay, this P option, it is very important. Basically, it will preserve its status, replication, block size, user group, permission, checksum, ACLs, lot of things. So if you see that this overall thing, right? So when you see that this is a permission, okay, then these are user and its group. Then this is the timestamp when it is created, and then basically multiple. And then it can also have some ACLs related to this particular directory or file. It preserves everything. It will just create as identical as what is here. So from the source to destination, it will create everything exactly similar, exactly identical. Okay, if you take option P. So this is what something we generally do when we do distcp, because we have to have identical information on both the ends. Okay, then few more things. Then you can update copying only only missing files. So let's use few of them and try to get its hands on. So delete means it will first delete the target files and copy everything from the source. Okay, or so this is how, I mean, if you see this command, I will try to show you. So if you say hadoop distcp -delete -update -p. So delete means what? On the target side, it will first delete everything and copy everything from source to target, and -p means it will have every property of the directory and their underlying files to be identical from the source to target side. Okay, so if I try to design this command, so I will write hadoop distcp. Okay, then we can have these things as it is, and web hdfs. So we will use web hdfs hostname and our directory. Okay, so web hdfs and hostname, we will put, what is our hostname on cdh? So this is the IP address. So let me just try to, because I otherwise we need to add it into our etc host file, right? And then our port would be 50,070 and the directory not here. So basically this should be our source, so we need to pick this one. Sorry, where is our HTTP? This one. And the directory would be wow, right? And it should now go to the other end. So 50,070 is your web HDFS, right? Web port. We can also use HDFS. We will see both of them. Is everything all right? Yes, everything is green. Now let me try this command. So I should run this from here. You can run it from anywhere because it doesn't matter. If you see, it is actually copying the data from, and it is running a map-reduce job. Now whose cluster will be used, from where it is actually getting submitted. Okay, so we do have YARN running on two different places, on Cloudera side as well as on HTTP side, right? And what it says, okay, so there is a problem in the configuration basically required. So it says map container capacity 512, virtual cores 1. So it is getting killed because it does not get that much capacity. So max container capability is 512 and map memory is required 1024. So let me just change that, because I just built.
Okay.
So what we have done is we have reduced the memory that we are trying to use for map task and reduce task to 56 MB. Okay, if you go to YARN, we have defined the maximum one to be, the maximum container size should be around 512 I have defined, and the minimum is 256. So it will not create the container unless it does not get the minimum required RAM, that is 500 that is 256 one, and it can go up to 512. Okay, just let me check there one more time. It says that map reduce source virtual core 1, max container capacity is 512, that is coming from there, killing the job. Map resource required memory of 1024. Now let me retry it, or we can make one thing, let it, because we do have plenty of resources, so let me make it till 1 GB. Starting around 256, it can go up to max 1 GB. Okay, so in that case we are good. So we can we can max run 4 containers at a time. So we have specified, so let's make it 5 containers. So I need to okay, so 1024 into, let's make 1024, what happened? 1024 into 5. So how much it is? 5102, 5120. So basically let's make the memory over here to (5120), right? So we can have maximum 4 containers, 5 containers, because we can go up to maximum 1024 on each one. Okay, this should be 256. Now save.
Himant, can you explain this? Sorry, I'm not able to understand.
No issues. 5 container recommended. No. Hive auto convert join. No. Okay, I will explain it. See, what happens is basically when you use yarn, right? So the yarn is your resource scheduler, in which the basic unit of work is your container, right? One container can run only one task at a time. For running any application on yarn, you require at least 2 containers. Okay, one is for application master, and remaining one is to submit the task and carry the things. And okay, so in the yarn main screen, basically you can define that the total number of containers those are going to run on yarn, how much capacity, how much RAM they are going to use maximum. So we have defined 5120. That is, the 5 GB of RAM can be used by all the containers running on yarn. Then we need to define that if you really want to create a container, how much minimum requirement of RAM is there. So we said 256 MB. Okay, we have plenty of RAM, but still we have created the container with very least memory, that is 256 MB. So it means that unless it does not get 256 MB, it will never be created. And once it gets created, it can go up to maximum 1024. That's what we have defined. So minimum and maximum RAM for the container. If somehow it try to use more than whatever is allotted, that is like more than 1 GB, any container, if it sees or if a node manager sees that any container is going to use more than 1 GB, it is going to kill that container. Okay, so that is it. Now some of the like Pig and Zeppelin, and then Spark, some of the Spark executor, basically they require minimum 896 MB of RAM for the container in which that task is running. Okay, so keeping 512 is okay for most of the jobs like MapReduce or Hive, but then for running Pig and for Spark, you may require minimum. But in actual production, basically you will have one container is having more around 16 GB of maximum RAM it can have. Okay, that's what actually I have seen in my production clusters basically, and you can have starting from 2 GB or 3 GB to around 16 to 20 GB per container. So per container, and then you can have around 100 containers, 200 containers total in yarn. So it means that 20 GB into 200 is like, or 20 GB into 100, it means that like how much? 2000. So 2000 GB of RAM you can put for your yarn containers. Are you getting me? So that huge, that kind of parameter settings you can do in production, real production. So let them restart. Okay, so we have increased the limit of the yarn container. Let me rerun it. We can also see this over here, 80, 88. So current distcp is running, accepted, defined. Let me check how many containers. So 2 containers, I think it should have started now. Map 0, reduce 0. And it keep grows if it finds more. %. So there is some IO exception. So this IO exception is basically it is trying to write the block, and to write the block basically it is trying to find, this host name. So what we need to do is basically we need to have the host name registered at least over here, so that it won't find any, So let me just update the etc hosts file on both the sides. So I will open this sudo vi/etc hosts, and over here also we do have sudo vi/etc hosts. So copy all of these over there, and copy all of these over here. And then we need to distribute this host file in the remaining hosts. Like so, CDH is having 2 more hosts, and HDP is having 2 more hosts. So what to do? Ansible Okay, so we have run this Ansible command, and we have copied whatever changes we have made in etc host on this master machine to other slaves, and same thing we may need to do on our HDP cluster. So I am coming here and just copying this. And it gets copied now. Now let me rerun that again. So we need to go to switch user hdfs. Okay, so this time it is succeeded. So what we have done is basically we have entered the destination hosts on both the etc hosts file. Now each machine of each cluster is able to see the other machine of the second cluster. Okay, so it's like kind of a complete cross connections among each machines, right? And now we should be able to see this directory over here on the Cloudera side. So switch user -hdfs hadoop fs -ls, and just do this. We need to check that how this directory looks like. Hadoop fs -ls / wow. So see, it has come, right? And the other thing is the timestamp. Just watch the timestamp on it. Also currently it is something different. It should have come similar to it. So let me just go inside it. Hadoop fs -ls Okay, now observe this. This is 1221. That is text dot this, and this is also 1221. Okay. Apart from that, this is this. So everything is matching now. Okay. So if you look both of them, they seems to be identical, and also the data. If you can get the data out of it, yes, you can. Hadoop fs minus cat, and you should see the same data. Okay, this is the same data that we are having. Now let me remove it from here, and now we will try from this end. So what command we have run? We have run this command, right? So let's say this yellow one was our primary cluster, this green one is our disaster recovery cluster. Now something has happened to our primary cluster and this file got deleted. Hadoop fs minus rm minus r. Wow, sorry. Okay, so we have deleted this directly completely from our PR, you can say, primary cluster. Now we need to copy it back on the other side. So which command we will use? Now this time we will try some hdfs, right? So we have, in this case we had used webhdfs. Webhdfs is this 50,070. This is the port from where we are actually accessing the name node and everything, name node front end. Now let me write this in the hdfs format. How we can do this? So we need to change this IP address, because now we are going to copy from here to the destination, that is here. And instead of web hdfs we can use only hdfs, and instead of port number 50,070 let's use 8020 on both the sides. So this should also work without any issues. 8020. And now we will run this on Cloudera side, so that we will get, so this is, we will run on our DR side and we will get it to PR. Now let me just check if that directory has gone. Hadoop fs minus ls. So yes, war directory is not there. So let me now run this, and this time it will use the resources of your Cloudera. Nothing, just like HDFS is the scheme, or you can say the way through which you can work through command line, and web HDFS is like from front end, browser based. Okay, it is stuck somewhere. Let me just check. So it says access time is not configured. So there is some property. Let me resume it. Okay, now the thing is, we had found one error, and the error was that there is a parameter called DFS name node access time precision was not set on the HTTP side. Okay, so we have gone here and we pick this HDFS config and search this property called precision, and it was earlier set to 0, and currently it is also like that only. So let me just refresh it. So we had set it to some value called 36000. So it is, I think, the time in millisecond. Okay, that is the response time in millisecond, basically, for this kind of cluster to cluster transfer. And finally we have copied the things. Okay, so you can just go there and try to fix it and make it to this value 36000. So it is a time in milliseconds. So this is just tell you the access time. Now go on HTTP side and try to see now you have got your webhdfs minus ls. Okay, so now we have seen both the protocol being used in distcp, either webhdfs or hdfs. Okay, and when we make the high availability of name node instead of giving the giving the primary name node machine either host name or IP address, we need to provide the namespace ID. So one namespace ID will have two name nodes under it. One is active and one is at standby. So we may need to redo this distcp once we get our HA done of name node. Okay. So because when you really work on this Hadoop distcp on cluster to cluster data copy, both of your cluster definitely 99% sure that they both are HA. HA means their name node and every masters on in that both of those cluster will be having high availability. Okay, configured. Okay, so in that case, basically the way you will deal with this distcp might be deferred. So instead of giving directly the name of active name node, again you may also need to check which name node is active. Okay, so suppose if you are trying to hit to the remote cluster, but then how will you know that on the remote cluster without going into that remote cluster, without logging into the remote cluster, how will you be sure that which particular name node is active name node, so that you can just configure it over here. Okay, that is also one of the case where the namespace ID is not working. So there are some critical some kind of troubleshooting cases that you may need to check while doing distcp. Okay, any questions?
Let's take a break, Mamad. No.